Hello, everybody. Cool. Sweet. Well, we'll get this show on the road then. So, see where everybody is. Okay, screw the stage. I can't do that. It's over there. Everybody's over here. You were all too lazy to walk over into the center of the space. That's all right. I may jump back up there, actually, though, because I got to press slides. But hey, all. I'm Gabe Bentz. I'm the founder and Slant 3D. Started up a few years ago. Basically, what we do is we're trying to make manufacturing about as easy to do as creating an app or anything along those lines, by making it so completely digital that nothing ever really exists until somebody actually purchases it from you. So you no longer have to ship stuff across an ocean. You no longer have to store thousands of dollars of inventory. You no longer have to get molds. So, just going to run through a little bit of that here for y'all. I'll stand on the stool right here. This feels right. So, if you were making something today, if you were going to make like a spatula or some kind of widget that you happen to come up with, or some piece of merchandise that you wanted to make, the process would be go to China, you'd call them up, you'd say, I need a mold. And before you even got started, you'd spend about $10,000 to $100,000 carving your design into stone. And then you'd be able to start getting your first part. When that first part shows up, you'd find out you screwed it up, and then you'd have to go do it again. So it's kind of an expensive thing to try to manufacture something, because it's so completely rigid and so high risk when you first get started, because you have this whole investment to hope and dream that it'll work out. And if once you get it manufactured, you get it shipped across the ocean, you spend another 10 grand for that, you store it in a warehouse for a year, you spend 10 grand for that, and then you realize nobody gives a damn about what it was that you created, so you really wasted your whole time. Comparing this monster to app development. Facebook was built in a weekend on a drunk dare, and over that time, he was able to basically just upload it to the internet and freely distribute a website or an app or anything else. That takes a kid with a laptop, and he can create a billion-dollar company, which is completely impossible if you're manufacturing something, because you're still weighed down with student loan debt or whatever it might be. So manufacturing something real is completely different from making something digital. But the technology has come along to where it is now possible to mass produce something for free. And the way we've started doing that over at Slant 3D is to use 3D printer farms. Giant 3D print. Okay, never mind. Wait. That was the original one. They're more like this today. So, printer farms. Printer farms use hundreds, if not thousands, of 3D printers to act just like a server farm does. When somebody wants to watch a YouTube video, server farm fires up, starts delivering the YouTube video to them. We use printer farms to act like a warehouse where the shelves make the product. When somebody orders a product from either one of our clients through like Etsy or Amazon or wherever it happens to be, or through our own sites like Angled, then that order is sent automatically to the machines. The machines automatically fire up, produce that product, and then it's pulled off the machine and thrown in a box. There's nothing else in between. If somebody is trying to produce 10,000 parts because they're going to sell a bajillion of these things next year and they're getting ready, they are going to, oh, awesome. I love you, man. Thank you so much. If they're going to sell a bajillion of them, then they can call us up and say, okay, we need 10,000 of these parts for this month. Can you make us 10,000 parts? And we'll say, yeah, sure. And you won't have the cost of the mold. You make 10,000 this month, you sell those off, then you do it again next month, and you sell those off, and you move on continuously. There's zero waste. There's not 25% of the Star Wars toys thrown away after Christmas or anything else, because everything is made when it is needed and when people want it. This is only possible with printer farms. Printer farms use the same plastic as injection molding, so we're able to access that entire supply chain and keep the costs low. And while a lot of people have a problem with 3D printers being slow, because it takes an hour to make a part, if you have 1,000 3D printers, you're now making 1,000 parts per hour. So it's really not that slow compared to any other type of manufacturing system. And again, there's no reason to produce as quickly as injection molding, because you're not trying to store up 10 million parts for the next 5 years and then be done. There's not a rush in it, because it never has to exist until somebody actually needs it. It is a warehouse where the shelves make the product. Since it's totally digital, it's now possible for a kid with a laptop to invent something. If you are reasonably competent and want to learn how to use a 3D modeling software or something along those lines, you can create a 3D model of whatever your widget may be, and you just upload it. And now it's available for sale. And you could sell one, or you could sell 1 million of them, and you would never know the difference because all you did was upload it the same way you would upload an app. You might improve it over time, you might upload a new version, you might modify it, you might create 10 or 12 different variations to find out which one works. Again, exactly like a website. Change the color, change the design, change what the actual features are so that you find out what people actually want. This has never been possible before with manufacturing because right there is $100,000 to $200,000 worth of molding cost to find out that nobody wants pig ears on their Echo Dot. But they might all want a stand to keep it from rolling off the table. But it makes manufacturing so completely digital that you don't have to fight with it anymore. And now you can take that risk. You can try as many different things as the software guys have been trying for the last 20 years. But with manufacturing, it's always been swing for the fences, think I'm smart enough to be the 1 out of 10 or 1 out of 100 guys who can actually sell something and be profitable. And as far as the scale, again, you have 1,000 machines or more, you can produce 1,000 parts an hour. 24,000 parts per day, keep on expanding that out to a week. I'm not that good at math, I don't care. It's a bunch. So right now, the biggest printer farm in the world that I showed you a little bit earlier is out in Caldwell. We have several hundred 3D printers operating 24/7, producing stuff like this. Whether it be commercial industrial products like this, iPhone stands, or whatever else it might happen to be. Maybe something a little bit more unique. Because again, people can just upload it to us. We've built all the site, all the infrastructure. We've built this manufacturing backend, this server farm of building stuff to where anyone, anywhere in the world can make something, upload it, and get it made. A kid in Zimbabwe can now figure out how to design an iPhone stand and upload it to us, and it'll be delivered to somebody in New York City 3 days after they order it. No one will know an item didn't come from a warehouse or that it was made perfectly on demand. So it eliminates all the waste, all this production cost, all the risk, and creates such an opportunity for new people to build stuff because it's no longer this walled-off secret garden of people who are wealthy enough to start trying to manufacture a product, but anybody who wants to try it and pursue it. Same way anybody who wants to try to write code can try to go make an app or a website. And this is what we've finally actually been able to achieve in the last year or so with the scale that we've had. With 1,000 printers, you can do all kinds of cool stuff. So, here with Treefort, we decided to push a little bit and see what we could do. When we figured out, okay, anybody can make anything, there are still going to be a lot of people who don't want to learn how to run CAD or 3D model or anything like that. But if you think about bands and music and influencers and merchandise, pretty much everybody only has the option of sticking your logo on a t-shirt, and that's what your fans get. And I don't know about anybody else, but I've got a sock drawer full of old t-shirts that I'm never going to wear again. So we wanted to use this to try to create some new products and new merchandise that people could actually utilize who are normal folks, who aren't a technical engineer who want to invent the next great spatula or back scratcher. So what we realized, we were messing around with it, and we're like, okay, what's a physical thing that we can make for music? And we were like, well, yeah, you could display your vinyl collection. And we were like, well, that's dumb. We don't need any more stands. You could create whatever stupid lamp or whatever it might be. But then we found out about this awesome Spotify barcode that you can scan with your phone, and it connects you to a playlist. And we're like, oh, that's interesting. Because if you were to do that in real life, you could print out a sticker and stick it to a cassette tape, which looks like a gross piece of crap. But if you turn it into something metallic and nice and embedded and collectible, now a band or a creator or somebody who wants to make something can just upload the link that they have. It is embedded into a cassette tape. And now if you're a classic physical media lover, you have a piece of physical media that you can store on a shelf, hold on, have a connection to your heroes with, but then just snap it with a phone and you have the updated latest music that they ever had. So we did do this with Treefort. Out there in the back, there's about 300 of these cassette tapes because we know the stands are full. You can take 2. We'll allow it. It's okay. But we made Treefort ones that connect to this year's set of artists and everything else, of everybody at Treefort. So it's a neat little collectible for you all. And yeah, you can scan that with your phone through the Spotify app anytime you want to and get it out there. We've been started doing this with all kinds of bands. So on the site, there are a number of bands who do merchandising through us. So again, they don't have a t-shirt with a logo on it. They actually have something that connects to what they're doing as a way of connecting with their audience. That's pretty much all I have there. Just kind of leaving you with the idea of the print farm. Generally, I could blab at you for an hour or more about this, but I think it's better to open it up for questions so people can actually find out what they want to know as opposed to what I think you all should know. So I'll leave it right there. Okay. Oh, sorry. I'm not respecting the mic. I apologize.
Okay, so I have my own mini farm. I have 12 3D printers at home.
Congratulations.
And my biggest what do you call it? The funnels, the smallest, whatever. My biggest holdup in production is when the prints need support materials. Do you have like dissolvable supports, or do you not print stuff with supports, or how do you automate that, I guess?
This is a rabbit hole. So my background is in product design and engineering, so I'm a snob, basically is what that comes down to. So I am always going to lean into the design is wrong if it's tough to manufacture. Design it so it doesn't need supports. That being said, there's some things that do need supports. From a technical standpoint, you have to do it sometimes. Sometimes you're gonna need a 90-degree angle that goes out there. The dissolvable supports are super expensive. But generally, if supports, there's recipes in some of this stuff, so I gotta be careful. If you tune your settings well enough, you can use supports with the existing current material, and it's okay. So tweak your machine more. Yes. Generally, talk to me a little bit after. There'd be more details about that. Generally, yeah, the supports are the bane of the whole process there. As we work through the whole digital warehouse model and that kind of thing, very often we try to work with clients to modify the design or only allow designs to where it comes off the machine done. And that's, again, why the printer farm is nice. We use FDM 3D printers. So a hot nozzle squirting out plastic. If you're not familiar with 3D printing, back in kindergarten when you rolled out a snake and made a coil pot, that's what 3D printing is. The FDM 3D printing not only uses a plastic that is very readily available through injection molding and that kind of thing, it also is the most reliable and stable type of 3D printing. People will argue about me on this with resin or powder-based systems, which are the other two types of 3D printing. We do not touch them at all, ever. We've tried them all. We've gone through every one of these. But resin and powder both have the problem of requiring post-processing now and forevermore, whereas FDM can have a finished part come off the machine, and nothing else can come close to that. While we could build a factory or an automation system that grabs a part, washes it, bakes it, and cleans it up and moves it out the door, it's just too much and will always be too much, whereas FDM is perfect right now and can get down closer. The argument everybody's going to bring up is layer lines. FDM leaves layer lines on the parts. So does wood. Wood has layer lines, and yet for some reason it's a premium material. So yeah, again, kind of from the design perspective, FDM leaves layer lines if you're wanting to do a quick functional part. But first of all, you can take those layer lines and make them smaller than a human hair so that they're practically invisible. If you want to be clever, you can actually apply textures to the part to hide those layer lines so that, again, it's no longer an issue because nobody would ever be able to tell. If you imprinted a diamond pattern or made the part fuzzy, or if you're printing with wood filament, let the layer lines stay, and now you have your own natural grain in there already, which we've actually done on a number of products. For a premium office products company worked with us, and we used wood-filled filament and the layer lines to create the grain. So again, if you design the part appropriately for the process, most of the problems with the process are just things that either aren't problems or you can be avoided, because every process has some level of limitations. The idea that everybody likes the smooth injection molded look, they don't all realize this, but that's because it's necessary, and injection molding doesn't work unless it's perfectly smooth. So I could say injection molding is a flawed process because you cannot possibly have textures at all. Otherwise, you're screwed. So the idea that a process is inferior in some kind of a way is just incorrect, because every process has its place. And again, if you compare right now, the milestone that we have with injection molding is we can produce 250,000 parts before a mold becomes cheaper than us with 3D printing. That's what we passed in the last year or so. We're probably not going to push it much further than that because Toyota considers 25,000 parts mass production, and we're at 250,000. I think 10 times better than the best manufacturer in the world is a pretty good metric. So 3D printing can have the scale. You can do mass production. You can do it quickly. You can do it affordably. The features of the process from an engineering or an aesthetic component can all be designed around if you're willing to adjust your design. Something I like to say a lot of times is that since we very often work in kind of an engineering discipline, we're waiting for a bunch of people to die who are so used to injection molding that they cannot adjust anymore. So as all the college kids come up who've worked with injection molding, it's coming along quicker and quicker because they have the skills and the willingness to try it out. Whereas more seasoned engineers would generally send us an injection molded design and try to 3D print it, which is always wrong and always a terrible idea, regardless of what process you're using most of the time. So there's a learning curve that's happening there, but right now the fact that the financial incentive to use 3D printing is so great, especially right now, thanks to COVID. COVID's awesome in that regard. Sorry, everybody, on the health side. Sucks on the health side, but manufacturing-wise, it's amazing. So it's been accelerating a lot because people have been forced to try new things. So it's been, the industry grew natively by 37% last year, which is unheard of, especially in manufacturing, which has been stagnant almost for the last 100 years. Yeah.
Have there been any significant improvements in 3D printing technology over the last 3 to 5 years that actually makes this more viable than it was 3 to 5 years ago?
So we actually, Slant 3D was started about 3 years ago. I was not interested in 3D printing at all when the company started because it was stupid. Everybody was touting 3D printing as a 3D printer in every home, like a microwave, and a 3D printer is not a microwave, it's a bandsaw. Easy enough to use for the average hobbyist, but you never have it in your kitchen. Nor does anybody want it when Amazon had one-day delivery for whatever your stupid doorknob is that you're trying to replace. So I was very against the idea. What forced us into it was 4 years ago when I was part of a product design firm, we created a series of STEM robotics kits, just little toys for kids to put together, that we designed to be 3D printed because we didn't want to buy the molds. And we thought we were going to sell 100 of them and be done. We ended up moving beyond 100 by quite a ways, so we had to build a print farm to produce them. And in running the print farm with the machines of that day, we realized that there were some very clear engineering solutions that we could implement to allow 3D printing to be mass production capable. One of the very simplest ones was, 1,000 machines, 1,000 parts per hour, even if it's slow per part. That's pretty easy to do, and the math worked out for the cost of the machines to make that feasible. What we had to do, though, was design our own machines. Every machine in this is a proprietary production FDM printer, optimized purely for 3D printer farms, so that they can remove parts on their own. They are very easy to maintain, and they're very scalable so that we can build 1,000 of these and put them into a farm and manage them. There is nothing off the shelf that can do that. There are many brands that are reliable machines and that kind of thing, but again, they're generally have some fundamental flaw that disallows mass production or maintainability long term. And as us building a manufacturing company where our goal was, okay, we're going to produce the same part today and the same part 5 years from now so that our clients can actually rely on us to make their pieces for them, there was no way we could have a third-party supplier of machines when 3D printers were upgrading every 18 months. So if there was not going to be guaranteed backwards compatibility and maintainability over time, there's no way we could have a third-party company producing our factory for us. So that was the reason we had to design machines ourselves. Up until a year ago, there was another company who was pursuing this model of the print farm. Their name was Voodoo Manufacturing. And I say was because they don't exist anymore. They built their machines on MakerBot machines, which was attributable to some of the problems that they had. But they also got hit by COVID because they were in New York. So there were a number of dominoes that fell there. But their machines were rapidly deteriorating, and they were reaching a stage after about 2.5, 3 years of operation where they were going to have to replace their entire factory in order to stay relevant and creating good quality parts over time. So that's why we make our own machines. It wasn't really necessarily a technological improvement that needed to happen. I would say that on certain components of our machines, they're actually quite out of date, but they're stable, and we know that we will always get parts for those because it's not the newest, fanciest thing that may not be here tomorrow. But they were engineered specifically for print farms, and they're the first 3D printers to be designed explicitly and only for print farms. 2 years ago, a year and a half ago, wow, this mask is terrible. A year and a half ago, we did release a consumer version of the machine, mainly for our clients who were wanting to do more prototyping in-house. So that they wouldn't have to call us up, hey, we need a sample. We send them a sample. They say that's wrong, and then we send another sample. We're just like, here's the machine. Get it the way you want. Send us that file, and we'll make 10,000 more because whatever comes off that machine is what comes out of the farm. So we made a consumer machine. That consumer machine is a terrible consumer device in many ways because it wasn't designed around user-friendliness. It doesn't have a touch screen. It doesn't have auto bed leveling because those two things are to make it easier for a schmuck. Apologize to people who have a printer in a place who love their bed leveling, but it's to make it easier for people. Whereas we're very bare bones, pure functional, build the machine square when you first get started, and you don't need the user-friendly features. Many of our machines are actually very headless. They have almost no interface whatsoever because they're all controlled through our cloud system. And people just wander around with a phone getting the status of each machine. So again, since they've been so focused on print farm, they can't be a consumer device, and a consumer device can't compete with them in this context. So that's why we design our own machines. Other stuff. Yo. Oh, yeah, I keep on forgetting about that thing. Project. It's okay. It's a small group. We can get away with it.
Yeah.
Okay. Hey, where are you? How are you?
So I don't know a lot about 3D printing in general. What kind of limitations are there on materials you can use? I know companies like SpaceX, for example, they have high-grade, high-tolerance steel parts that they're creating.
Mm-hmm.
So could you speak to that a little bit more?
So aerospace has the benefit of unlimited budget and really specific necessities, especially SpaceX right now. But 3D printing, okay, it's a broad question. 3D printing its primary limitation right now is certifiability. Do you know what is going to come out of the printer? Because there's so many variables in it. There is the printer itself, which has a proprietary control system, piece of software, and wiggle in the gears that is unique to each type of machine. You have the software that takes a 3D model and turns it into machine code. And it may shrink the part or raise the part or change the flow or whatever it happens to be based on the 300 settings that exist inside of that. That some company like us has created formulas for that are then our formulas using those baseline parameters. So there's variability there. And then based on what raw materials you're using from what supplier, they may expand or contract or whatever it may be. So the biggest limitation with 3D printing right now is that you cannot simulate the part before you make the part. Basically, fundamentally there. Because since you have all of these variables, the only way to verify that the part that you're going to get is the same as the part that you imagined in your mind or created in software is to print it out and then go test it. Aerospace has the advantage of needing to test their rocket engines before they launch them anyway, so this flows right into that. And again, unlimited budget, so they can do it 3 or 4 or 10 times. And even with good manufacturing, there's generally errors that would cause problems anyway. So 3D printing has a problem with reliability and consistency over time. And this is only really being addressed at a company level. Like for us, we very highly vet our certain certain suppliers. We use the exact same machine throughout the entire facility, so there's not variability between those. And we use the basically same recipes. But variability is the big one. SpaceX and everybody else who's doing aerospace has the budget and has, since 3D printing allows a control of a part that is impossible with anything else, CNC machining can't create a curved S tube inside of a brick. 3D printing can. And sometimes you need a curved S tube inside of a brick, but I don't know why, but it's possible. So the control of how a part is made and behaves and the components within it is something 3D printing does very well and is very useful in aerospace. Very often it doesn't expand very far beyond that. Like right now, metal 3D printing is very super hyped. And there are plenty of companies getting very rich off of that hype, even though they haven't really delivered anything yet. So metal 3D printing, I'm in the 3D printing industry. We keep an eye on it, and we're trying to justify it. But we have not seen an application of metal 3D printing outside of aerospace that is clearly and obviously better than machining or casting. Because nobody has made a watch face that is so complex that you can't make it any other way or something along that line. Again, it's kind of the design language. If you're using the 3D printing process fully, you can create something really weird that can't be created any other way. But not enough people are thinking that direction to utilize metal printing in that way. So printing is trying to say, well, we're as good as casting or machining, but casting and machining are both better than metal printing right now. So there's a limitation of not utilizing the process enough to control a part, and the certifiability of that part when you get it are kind of big challenges. Hopefully that made sense. Cool. What's up? Next microphone over here.
I was just gonna ask, do you like exclusively use PLA or do you use ABS and PETG as well? And do you make your own filament?
Yes, we do.
That's that's so cool.
I'll let you know a secret. If you make your own filament, you save about 70% on the cost of the filament. And for us, when we're going for mass production, we want to be as close to the raw cost of those beads.
Yeah, that takes you down to like injection molding prices.
Exactly. Injection molding stuff. To make something for 15 cents, we need the raw material to be less than 15 cents. So we do make a lot of our own material. Generally, it's kind of in basic colors and that kind of thing, because right now, again, the material supply chain is all jacked up in 3D printing, because since it's all consumer-based printers and machines, a guy in a garage doesn't notice that this black is a different black from one month to the next. Whereas when we buy, 2 tons of the stuff and burn it up in about 2 weeks, we kind of notice that black is a little bit off from that, and that one has some blue mixed in, and here's some red, because somebody's eyeballing it when they were making the filament. So we're very sensitive about that and try to control it as much as possible. As far as materials, when we designed our machines, we designed them to use basically everything. So anything from super soft TPU rubber all the way up to carbon fiber infused nylon to replace aluminum parts. Our machines run all of that stuff.
Do you make your own like equivalent of nylon X
No.
and TPU and like wood filament?
Nah, you
No.
got to be special to do that kind of
Okay.
stuff, or really, really patient, one or the other. There's guys who do it better than us. And if there's our suppliers out there who can consistently create a good quality product and do it better than us, I am happy to work with them and love it. I am frustrated with our organization that we have had to create so much of the stuff that we use. Because back when we were first starting the first project that made us build the print farm, we were like, we'd love to just farm this out to a print farm, but nobody had a print farm that was any good at that point. So we had to build a print farm, and then we had to build the software to control the print farm, and on down the road, because there's just nobody else out there who is doing it, or doing it well. So if we can find somebody who's making carbon fiber who's good, which are quite a few folks right now because it's a very popular material, then we'll use them, because it's less responsibility on us to do that. Other questions?
I have like 20 million.
Go for it.
I went to the bathroom in between sessions, so I think I missed the beginning of how do your bed surfaces work? Like, are they the kind that like get sticky when they're hot, and then when they cool down, it's like, whoop? I don't know. Does that make sense?
Yes.
Okay.
That's as far as I can go into that, because the beds are something that we keep kind of
They're like
close to the
secret.
chest.
Okay.
The auto ejection and the automation that we do within the machines is that material science, and the years of effort that we've put into that, we do kind of control.
Yeah,
a little
that's.
bit. But it's a little bit of everything very often. But yeah, a few special sauces here and there and yonder.
Nice. Anyone else? Did you have a question? How big is the staff? Like, how many people work for your Slant 3D?
Right now, about 9 or 10, I think, are full staff at the moment. We've got about, a few folks out here at the main factory. And then we have people in our Austin office working down there. and then a number of remote guys who are kind of all over the world, quite frankly.
Nice. Let's see. Now I'm forgetting my
Yeah,
questions.
we were remote before it was cool or required.
What about when like a roll of filament runs out? Do you have to like manually go put another roll on?
We do.
Okay.
There are people who are down here changing spools.
Yeah, got it.
You
Okay.
save some effort on that by using big spools,
Yeah.
and all of our machines have filament sensors and that kind of thing, so that they pause when it runs out.
Yeah, nice.
And notify people. But right now, it's about one person per 150 machines to keep them operating.
Yeah, that's awesome.
So, yeah. When we first got started, we were looking at 3D printing, and we're like, well, everybody else has a printer farm over there, and they print the parts, and the parts cost this much, but then they have somebody standing around waiting to pull off the parts the whole time. And that's where all the cost was. So we thought, okay, we get rid of that person, and now we can be really effective at mass producing parts if we can make an automated machine. So that's what we focused on. So yeah, when a part is done, when most parts are done, especially in production runs, the machine will shove it off, move on to the next one, and do it continuously. So we don't do, if you're familiar with 3D printing, a lot of people will try to put 50, 20 parts on a bed and print it all at once. We hate that so much, because if one part goes, they all go. And you just lost 100 parts rather than one. So we do produce one piece at a time serially.
That's
Serially.
so nice. What about, I was gonna ask. I put in a lot of my products. I have like pauses programmed in to like put magnets in or bearings in.
Ooh, fancy.
Do you do any of that, or do you?
Yeah, we have that kind of stuff in there.
Nice.
We're not always fans of it because, again, it's really high
It's
human
yeah.
touch. And a lot of people don't think of it that way. Don't think of those features of like, yeah, I can embed a screw or a nut or something inside here and make it really awesome. Most people are always like, can you print threads? And we're like, no, but we can put threads in.
Yeah.
Very often, we're not big fans of the implant, though, because it is tough.
It's so much labor. Yeah.
It's labor, and it's hugely impacts machine time. Because if it pauses at 5:15 after everybody goes home, you just lost a whole night of print time on that
hours,
machine.
Yeah.
So generally, if we're trying to put threads into parts and that kind of thing, we'll recommend like heat inserts and that kind of stuff, which is generally just fine.
Yeah.
But if we're able to embed something cool, we want to. Most of the time, we've actually used that most for like changing the weight of parts. Because we love to try to make like a super ultralight part that is quick and easy to print, and then we fill it up with sand so it feels heavy and high class. And that's how we get away with it. And nobody can ever see a plug hole or anything else because it was
It
printed.
closes itself. That's so cool.
So that's generally where we've used the enclosed stuff inside of it.
And that's not automated, right? It's like you
No.
get an alert that it's paused, and then
It's
you go
paused, somebody's
pour
gotta go
sand
dump
into
something
something.
in there.
Okay.
Yeah, exactly.
Nice. That's
So there's still that. We haven't gotten quite that fancy. We do not run multi-extruder machines. I hate multi-extruder machines.
Multiple colors or like dissolvable. Okay.
Yes. Because if you have two nozzles, you just doubled your chance of screwing up the part.
Yeah.
Because the other nozzle that's not working is always in the way doing something it shouldn't. So we do run single nozzles. And while within the industry, everybody's like, single nozzle, you pedestrian. You can't do multiple colors. Nobody wants multiple colors. We haven't had any clients who have said, by golly, we need white plastic on top of green plastic, and we cannot possibly use paint on raised letters. So we never cared about multicolor because it wasn't something anybody was asking for. The industry decided that it was something important for them, and nobody else cared. So we made single extruder machines. And again, the focus of these was always to make sure that they operate continuously with very little human intervention or breakdowns. So they are the barest minimum that we could possibly make and create a three-dimensional moving tool. But yeah, what's up?
Thanks. So you talked a little bit about monitoring the machines. Could you speak about kind of interfacing with the firmware a little bit and what metrics you're checking on for each of the machines to make sure that they're running, and maybe even like talked about like a cloud service that's interfacing with it too?
Yeah, we built a whole cloud system that controls the farm and lets us to see the status of every machine all the time. That system also runs our ML software. So each machine has a camera on it, and we've been collecting images now for quite some time that are making the machines slowly and continuously smarter, so that we can decrease the amount of input people have to continue to do on these things so that they can self-diagnose. It's like, I'm plugged, it's jacked up, I pull it off, and then actually potentially fix themselves. As far as the status messages and that kind of thing that we track on them, we pull anything we possibly can. Anything that will go through the data hubs of these machines, we will try to collect and store, because we don't know when that's going to be useful, quite frankly, or when it's going to be relevant for that long-term learning and affiliation and deep learning. So everything from temperature to the position of the head when the temperature changes or fluctuates to all of that stuff we contain and control. The parts going through it, the history of the machine, what kind of maintenance that machine has had on it, so that we can diagnose ones that have just been problems continuously, to where they just need replaced inside the system. And then outside of that, yeah, everything that we can. We grab the whole kitchen sink if we can. There's been some limitations on that just because this is a slight limitation of the hardware that we originally used when we first started designing these machines. A year and a half, right now we're on version 10 of the machines. Or version 9 of the machines is active throughout the farm. It's about the previous 200 machines or so. Version 10 is just about to be turned on and will be the next 800 machines, for both the building out this final facility and our Austin office. The way we're actually doing the branch offices is we're trying to get closer to where the customer's buying parts. We're literally just building 3D printing fulfillment centers. We don't want to build another facility like this. We don't want an office with a factory that we then put machines into. We are actually going to be building a 3D printer factory up here in Boise, where basically you have a shipping container full of 3D printers. That is its own self-contained system that we test, verify up here in Boise, and then ship to wherever we want it. And then plug it into a wall someplace. And it's operational and working. And those little drones will be very, very autonomous. With the V10 machine, everything should be durable enough to where almost no person needs to maintain it or work on it at all, so that we can just have somebody go in and basically put parts in a box and ship them out to the local area that day. So there will be the Austin office, which is the first test and beta of that. And then our next factory is going in at Louisville, Kentucky. And that's significant because that's the hub of the UPS distribution system. So we're halfway to anywhere with anything that we're shipping for our clients or for our sites.
Well, you've sold me then, but I'm guessing you're not a public company.
We are not.
Okay.
We're still startup-y.
I was curious about kind of the other side. I think everybody in here is kind of a nerd and is interested in 3D printers and has tons of questions there. But I'm curious, for your actual customer side, I'm guessing you want it to be a black box experience and be as simple as possible. So if Joe Schmo out there has an idea and they want to produce it and sell it on Etsy, I'm wondering if you could kind of walk us through what that process would look like to them and how that product would go from their idea to the end customer.
Absolutely. Yeah, for that whole, it is invisible. Anybody who's buying a product has no idea that it's 3D printed. We don't use 3D printing as a feature of any of the stuff. We take a photo of the product that is being 3D printed and post it there and honestly present it. But we don't say 3D printed any more than people say, this is an injection molded spatula. By golly, don't you want it more now? Nobody cares. So we make sure that good products come onto the site. Right now, the site where submissions can happen is angled.io. So that's where people can send up a model or anything along those lines. Right now, we just did a huge website design. So for like the next month or so, submissions are kind of paused, just as we make sure that the customer-facing side of it is all working appropriately. In our previous submission site and with the new versions coming up, somebody has a 3D model, you need an STL model or an OBJ. That's the baseline. That's the final one. Don't try to submit us your CAD files or anything else. We don't care. We don't want them. When you submit them, right now we are curating the site because we don't want to just bulk upload Thingiverse or something along those lines. We also don't want to have to deal with the licensing problems that incurs. So somebody who submits it, we need to make sure that, number one, it's their design, and make sure that it's actually a good product. So our team is going to go through and say, is this cool? Is this interesting? Does this fit with what we're doing on the site? Or is it somebody's trying to submit a dildo again? I mean, seriously. It's a problem. So we are sorting the parts here for the time being. So once you submit a part, it generally takes like 1 to 2 weeks for it to kind of be evaluated, for us to do a test print. And then our team does photography, test print, and product listing. When you submit it, you can submit any sort of copy or listing and that kind of thing. And when it goes live, you're notified and say, here's your listing for your product. If you're a consistent designer or a continuous designer who's created multiple things, Then we turn you into a featured designer, and then you have your public profile page and kind of the story of where your stuff is coming from. We've done this with like YouTubers. Like if anybody's like an uber nerd here and knows like Make Anything on YouTube, Devin Montez, he made a game called Tippy Tree. Ah, darn it. Not deep enough in the industry. You think you're 3D printing fans. No. But anyhow, Devin's a YouTuber, and he invented this game. And he wanted to merchandise it for his YouTube channel because he doesn't want to have to 3D print stuff for an Etsy store because he runs a YouTube channel. So he became a featured designer, and he submits basically his weekly YouTube ideas to us that are then available for anybody who watches his videos. And it's great for him because he has an implicit kind of marketing system there from his fan base. So instead of doing the t-shirt, he's actually selling the things that he's created and designed. So that's kind of the full life cycle of a person. Here in the new year, we are trying to get the site updated so it is more YouTube-esque and it's just free and open season. We just have to build some more sites and kind of moderation into the system to make sure that we aren't overwhelmed by garbage or unlicensed products and that kind of thing. So we push really hard on that kind of stuff.
Were you like mechanical or electrical or something else in college, or did?
I am a robotics engineer by training.
Oh, that's awesome.
Mechanical engineer focus, but yeah, robotics in general. So I touched everything.
Where did you go?
Points to you if any of you guys know this school. Embry-Riddle Aeronautical University. Attaboy! Nobody knows Riddle, unless you work for Boeing. Embry-Riddle is an aerospace engineering school. Okay. I went there originally because I was planning on going into the private space industry. But then I looked back at my previous work before school and I realized, I built robots kind of my whole life. Maybe I'm in the wrong thing. So I switched over to ME and finished up in that. But yeah, ME was great because I got to touch a little bit of everything. So I've worked in, before this company, I was in very heavily in personal robotics.
Nice.
So Roombas and that kind of stuff. So I got to mess with all kinds of stuff. Yeah.
Anyone else?
Other things? You had 20 questions. You only asked like 4 since then.
I know, now I'm forgetting all of them. I don't know.
What are they? How much time do we have?
Like, I think most of my questions would probably be better like one-on-one
Oh, fair enough.
and bore everybody else. Yeah.
Well, I think we just about hit time anyhow, so that might be perfect timing there. We started late, but that's okay. Nobody needs to have more than they deserve. Well, thanks, guys. Appreciate you coming by. Feel free to talk with me after. And, yeah, grab some cassettes over there because we got them all stored up.